Hi, Algebra 1. Nice to have you back. This is from our old workbook, so please have your old workbook. Let me know if you happen to get rid of it, but hopefully you did not. I had asked you not to get rid of it, but I'm going to be on page 211. And what we're going to be doing is we're going to be graphing two different equations. On the same thing. We're going to try and figure out where they cross. So remember, this one is set up as y equals mx plus b, where 0 comma b is the y-intercept and m is our slope. So that means that 0 comma 1 is our y-intercept, so we're going to put a dot right here. And we have a slope of 3, but we'll make that a fraction, so it's 3 over 1. So from here, I'm going to go up 3 and right 1. And I'm going to try and draw as best I can a straight line that goes through those 2 points. The second problem, because x and y are on the same side, we're going to use the cover method. Okay, so remember this was 0 comma blank and blank comma 0, where this is an x value. So we're ignoring the x, so y is equal to 6. So 0 comma 6 is up here. And then this is a y value, so I'm going to cover up the y, so that means I'm going to get 2x is equal to 6, divide each side by 2, so x equals 3. And notice these lines appear that they're going to cross each other when I double check this. So if I look right here, this is where they cross. That cross is at 1 comma 4. So this is the answer or the solution. They might ask it one of two ways. They might say, what's the solution or what's the answer? So that's basically how you go through these problems. It's best if you, on your paper, if you have something as a straight edge that you can make your line straight. I happen to get kind of lucky because I drew easily. Okay, so let's go ahead and put another graph right there. I'm going to move this over a little bit. Our next problem on page 211 is we have y equals x plus 5 and y is equal to negative 4x. So these are both set up as y equals mx plus b. So our b value here is 0 comma 5. That's our y-intercept. So we're going to go ahead and plot that right here. And then I don't have a number out front, so I'm just going to put a 1. So my slope is 1 over 1. So I'm going to go up 1, right 1. And again, try and draw a straight line best we can. This one, we're missing a value, so it's plus 0. So that means that 0 comma 0 is our y-intercept. So that's at the origin. And then I have a slope of negative 4 over 1. Make it a fraction. So I'm going to go down 4, right 1. And then I'm going to connect and realize that our lines cross each other. So that maybe appears to be where they cross at. Maybe negative 1 comma 3, maybe. Okay, and the reason I want to say maybe is sometimes graphing isn't the best way to solve these. We will see over the next couple of days better ways to do it so we can get the exact thing, because we don't always draw the best that we can, right? Make sure if you have any questions you ask me. Okay, so let's put another graph up there. Move that over. I'm on page 212. So they tell me that this is the solution of this. And do we think they're right? And I'm going to have these two equations that are written. Okay, so let's this might be the answer. So let's Let's plot that. 4, negative 3. It's like right there. That might be our answer. Okay, but let's see if it is. First one I'm going to take a look at, this is set up as y equals mx plus b, so I get 0, comma 5. So 0, comma 5 is up here. Then I have a slope of negative 2 over 1. So I'm going to go down 2 and right 1. And this looks to be nice, so it's definitely going to be on our blue line, which is great. Now let's see if it's going to be on our next line. This one's going to be the cover method, so 0, comma blank, and blank, comma 0. So remember, that's an x value, so let's cover that up. So I get 2y equals negative 2. Divide both sides by 2, so you get y equals negative 1. So 0, negative 1's right here. This next one, this is a y value, so I'm going to cover that up. So I'm going to get x equals negative 2. So negative 2 is right there. And look at that. Yes, this is the solution. This is the answer. Okay, so sometimes they might give you something to verify if it does work. It looks like they did the same thing on number 2 as well. Oh, and they're saying plug them in. So let's do this next one. We have 1, comma 5, and then we have this. I'm not even going to graph these. Let's see if what happens when we plug them in. So I have, these are my two equations. So I have an x and I have a y. So I'm going to take this x, I'm going to plug it in here, and the y I'm going to plug in here. So I get 3 times 1 minus 5, because this minus has to stay as that, equals negative 2. So I get 3 minus 5 equals negative 2. So that would tell us that negative 2 is equal to negative 2. That's true. So that means it works on the first one. Let's see if it works on the second one. My x and y again. I'm going to plug my x in here and my y in here. So I'm going to get 5 equals 2 times my x value is 1. So 5 equals 2 times 1, which is 2, minus 3. Is 2 minus 3 negative 5 or equal to 5? No, it's equal to negative 1. So no, this doesn't work. This is not a solution. If I had gone back to that other problem, let's just go back to this. Let's plug this in, see what happens. I have an x and I have a y. Let's plug those x and y's in here. So I'm going to get negative 3 equals negative 2 times 4 plus 5. So I get negative 3 equals negative 8 plus 5. Negative 3 equals negative 3. That works. And we've already verified this works with our graph, and I know you don't have a graph on there. And again, let's plug it in here and here, see what happens. So my x value is 4 plus 2 times negative 3. Is that equal to negative 2? So 2 times negative 3 is negative 6, equals negative 2. So is negative 2 equal to negative 2? And that's also yes. So when we plug it in, if we are given a point, we plug it in, we can verify that we have a solution. Okay, this last problem at the bottom of page 212, I'm actually going to have 3 graphs on there. And let's copy that. Paste that. And paste one more. And I'm going to draw the best I can. Let's see that. The first one looks like it crosses at 2, negative 1. So it's there. And we have a line that does this and a line that does this. And then we have this other one where we happen to have 2 lines that happen to be parallel to each other. And then this last one, we have just 1 line shown. This means there's 2 lines that are drawn, but let's take a look. So they gave us y equals 2x minus 5, y equals 1/2 x minus 2. So that's what this looks like. So how many times do my lines cross? They cross 1 time. So that means we have 1 solution to the problem. Okay? This is like we've seen before. We have one solution, but sometimes you might graph, and these graphs, if had drawn these in, would look like the graphs below, which these are parallel. And parallel lines don't cross. And if they don't cross, that means you have 0 solutions. So it's easy when you graph. What tells you if you have parallel lines? It means that the slopes happen to be the same. So you can't really see the slope of the second one, but by looking at the lines, you can count up and over and out, up and over, and they're the same on both. So they're parallel lines. This last one, if you happen to graph your equation and you get one line out of it, that means it's the same line. And if you have the same line, that means you have infinite solutions. Okay, so let's review. If the lines cross, one solution. If the lines are parallel, no solutions. And if you get the same line, you happen to get infinite solutions. Okay, so what I'd like us to work on is on page 213 and page 214. Looks like problems 1 through 4, you're just plugging in the point to see if you get there. It's true on both. If it's not true on both, it's not a solution. If it's true on both, it's a solution. And then 5 through, let's just work on 5 through 13. And these are just graphing. Okay. I will have these worked out for our video for tomorrow, so you can double check them. Have a nice day. It's nice to see everyone back at school. I'm happy to see you.